In this video, I'm going to be walking you through a trading strategy that trades the S&P 500 index, which uses a mixture of linear regression for trend analysis and the MACD line for trade confirmation. Stick around until the end of this video to see the results on a 4-year backtest, and as always, all of the code and data will be available on my GitHub, which will be linked below. We're going to begin by importing the libraries that we're going to be using for this video. The first is pandas, the second is the MACD line from the technical analysis library for Python. We have backtest and strategy from the backtesting.py library. And then for the linear regression, we're going to be using stats models. So we're going to import statsmodels.api as SM. So I'm going to run that now. The next step is to load in our data. So I'm going to insert a cell below, and I'm going to create this variable called full data. And this is going to read in a CSV file of our S&P 500 index data for the last 4 years. So this is going to be 15-minute interval data. So I'm going to load this in using pandas, and then we're going to enforce our date column to be a date time column so that the backtesting library knows how to interpret this when it goes through the backtesting. So I'm going to run that, and we're going to load our data. The next step is to create our MACD indicator. So I'm going to insert a cell below, and we're going to create this variable called indicator_MACD, and we're going to use the MACD function that we imported at the top here. We're going to define our close price as the close column in our full data that we read in here. We're then going to create a new column within our full data, and this is going to be indicator_MACD.MACD. And then we're going to do something similar for the signal line. So this is, again, using this variable up here, indicator_MACD, MACD_signal. And I'm going to run this, and we're going to have a look at what the data looks like. So we have our date column, which is our date time object that we enforced up here. We have all of the other variables that we need. So we have the open, the low, high, and close, also the volume. And then we have our MACD and our MACD signal line that we created here. Now, the first several rows are going to be missing. That's just because the MACD uses the previous data in order to calculate the future values. So that's nothing to worry about there. Now, the next step is to create the strategy itself. Now, I'm not going to paste in the whole thing at once because I want to go through it kind of line by line just to show you how it works. So what we're going to do is we're going to create a new class, and I'm going to call this linregstrat, short for linear regression strategy. And this is going to inherit from strategy, which is what we imported at the top from the backtesting.py library. Now, within this class, I'm going to define some variables. And these variables are going to be optimized, so it doesn't really matter what we set them to right now. The first two variables I'm going to define is going to be our take profit and our stop loss. So I'm going to call our take profit just TP, and I'm going to make this just 1% for now. Obviously, we're going to optimize these, so it doesn't really matter what we set it to. And the same with the stop loss. Now, the next two variables I'm going to create are going to be specific to the linear regression aspect of this strategy. So the first is going to be called long_min grad, short for the minimum gradient we need to open a long position. So I'm just going to set this as 1 for now. Now, with a linear regression, when we compute that, we will be able to access the gradient of the line that is created, that is plotted against the close prices. Now, if that line is positive above 0, it's going up. If that line is below 0, obviously the trend is negative. Now, depending on how great that number is, or how small that number is, indicates the strength of the trend. So we're going to create another variable as well for the short position. So I'm going to call this short max gradient, because we obviously don't want this to be greater than 0. So obviously the lower this is, the stronger the bearish trend. The next variable I'm going to create is going to be one called time since crossover. Now, this refers more to the MACD crossover. Let me spell that correctly. Now, this refers more to the MACD line. Now, because we're using two indicators technically here, right? We're using linear regression, and we're also using the MACD. We don't necessarily need the MACD line to have crossed through the signal at the exact same time we have a favorable gradient for the linear regression. This could happen perhaps, an hour before, maybe 15 minutes before, right? We're dealing with 15-minute data, so 1 would be, it could happen 15 minutes before. 2 could be it happens 30 minutes before, right? It doesn't have to happen at the exact time of the linear regression gradient becoming favorable, so we can leave this as 1 for now and let the optimization that we're going to do later on optimize this number to make our strategy as successful as possible. Now the final variable, and this is the last variable that we're going to be optimizing for this strategy, that the strategy is going to be using, and that is going to be called window. Now I'm going to set this to 500 for now. What this basically is the number of data points we're going to be using for the linear regression. So 500 right now will take the previous 500 close prices and use that to calculate the linear regression, which is what we use to determine what the trend is. Now again, we're going to optimize this further, so it doesn't really matter what we set it to right now. But these are all the variables that we're going to be using. So we just have 6 variables here, and obviously all going to be optimized, so it doesn't matter what they are right now. Now, before we continue, we need to have the initialization function in here. So just write init itself, and then within this, just 3 dots, shorthand for parse in Python. After this, we're going to create our next function. So this is the function that's called for each time period during the backtesting. Now, within this, we're actually going to wrap everything into a try and except. Now, the reason for this is for the first several iterations through the data, we're not going to have enough data to compute a window's worth of backtest, a window's worth of linear regression. So it will actually take 500, if we set this to 500, it will take 500 iterations through the data before we have enough data to actually calculate the linear regression. Now we know this is going to be the error, so we don't really need to concern ourselves with fixing it. So just to make things simple, I'm going to put this into try and accept. You could introduce some logic to capture this, but I'm just going to leave it like this for now just to keep things simple. Okay, so within this, I'm going to create a variable called current price, and this is going to be equal to the last close price that we have available to us during the backtest during this particular time period. The next is going to be the MACD. Now, what we're saying is we're going to take the MACD that is not necessarily the last one that we have, but it's the one that is the number of time points stored in this variable here. So if this was set to 4, then we would access the MACD from an hour ago, or 45 minutes, because -1 is the current time. The next variable that we're going to add here is the previous MACD, so just the MACD before this MACD here, and this is going to allow us to determine whether a crossover has happened. Next, we're going to do the exact same thing, but for the MACD signal line. So at this point, we've created everything we need for the MACD aspect of the strategy. The next is to calculate the linear regression. So we're going to define our model. So we're going to use the stats models library. And from this, we're going to use something called an ordinary least squares linear regression. So the goal of this linear regression is to minimize the sum of squares from the linear regression line and the data points surrounding it. Now, the input to this is going to be our previous prices. So this is our y variable. So this is our dependence variable, and then we have our x. So this is just a range from 0 to the length of the previous prices. So whatever that is, but that is our independent variable. And then we want to fit the model, and after fitting this, we want to access the gradient. Now, it's worth mentioning that because we're calculating a linear regression for every single time point within the data, it can take a bit of time to run this backtest, more so than if you were to just rely on traditional technical indicators. So that's just something to bear in mind. It does require a bit more computational resource. So that's everything in terms of the linear regression aspect. The next is to create the entry signals. So the first thing we're going to do is we're going to create an entry signal for a long position. So to do this, we're going to say if all, and then we have a list of the different criteria we need. So we need the MACD line to be greater than the signal line, but we want the previous MACD to be less than the previous signal line. So that indicates the MACD line has crossed through the signal line in the direction required for a long position. And we also want the gradient from the linear regression to be greater than this long min gradient here. And then we're going to enter into a buy a long position. So we're going to set our take profit as the current price multiplied by 1 plus our take profit. Similar for the stop loss, it's just 1 minus the stop loss. And then we're going to do the exact reverse for shorting. So we're going to say The MACD has to be less than the signal line, but then the previous MACD is greater, so just the reverse from the long positions entry criteria. And then the gradient should be less than or equal to the short max gradient variable here. And then for selling, it's just the reverse of the buying. So obviously the take profit is going to be below the current price because we're shorting, and the stop loss is going to be above the current price because obviously it's a short position. Now, before I continue, there's one thing that I forgot to add, and we need to define our previous prices that we're going to be using to calculate the linear regression. So I'm just going to add that here. So we're going to run that, and we can run our first backtest using the default parameters. So we're going to define our backtest as BT, our backtest equals backtest, which we imported at the top. We're going to input our full data, the strategy, we're going to say our cash is 100,000. I've set a commission as 0.2%, and we're going to be using a margin of 1 to 5. And I've set exclusive orders to false, and we're also going to enable this strategy to hedge as well. So that means that I can open long and short positions at the same time. And we're going to run that and just see what the results are just from the default parameters. And we can see we've got a minus 96.5% return, right? Not very good. So let's move on to the optimization and see how much we can improve this strategy further. So I've defined some hyperparameters here for the different variables that we're going to be inputting into the strategy. So for the long min gradient, this is going to be from 0 to 2. We're dividing the n by 100 for every n in this loop up to 200. So we're incrementing by 0.01 at each step. And the same for the short max gradient, apart from it's going to be obviously a negative. For the take profit, we're going from a very low number, so 0.25% all the way up to 5%. The same for the stop loss as well. The time since crossover, we're going from 1 to 32. Now the window, we're going to use from 100 to 1,000 different time periods to calculate the linear regression. In fact, I'm also just going to add 50 to that as well, just because smaller values might work better. And then we're going to add a constraint. So we're going to say the take profit has to be greater than the stop loss. And I've set our max tries to 200 just because I want to cover a lot of bases with this optimization so that we can really try and optimize this as much as possible. So we're going to run that, and bear in mind, this is going to take quite a lot of time to run depending on the computer that you have and the compute resources you have. So don't be surprised if this takes quite some time. For me, I think it took around sort of like 10-15 minutes. This will obviously change if you adjust your max tries, but I'm going to leave it to 200 just so we can cover lots of different combinations. Okay, so this is now finished running, and it probably took about half an hour for me, realistically. But let's look at the results. So we see that the final return is 104.7%. So really good return, a lot better than buy and holds over the last 4 years. So overall, the return is pretty good, but that does not mean that the strategy is necessarily robust to go and put into live trading mode. There are certain issues that would need to be addressed with this strategy. So for example, the max drawdown is really high. So we have a 90% max drawdown, so that would definitely need to be improved. And if we look at the system quality number, so we have a number of 0.7. Now, ideally, you'd want this to be above 2. So 0.7 is not that great. So there's ways that this can be improved, but this is definitely a good starting point for a strategy that could be optimized further. Perhaps you could add some additional technical indicators, some additional entry rules for this strategy in order to improve it further. But that's everything for this video. If you enjoyed, please give it a like and subscribe for more content like this. As always, all the code will be in the description below in the GitHub, along with all of the data. So thanks for watching, and I'll see you in the next one.